Good afternoon, my dear students. Without wasting any time, let's start today's topic. As you know that we are doing our unit 11, that is P block element, in which we have done boron family, we have done carbon family, and yesterday we have started the carbon also. Today I'm going to tell you about the important compound of carbon and silicon from group 14. The important compound of carbon and silicon from group 14. So there are some important compound like carbon monoxide, which is given formula CO, carbon dioxide CO2, silicon tetrachloride, silicon halide, silicon oxide, and silicones. These are the basic compounds. One more is silicates. So very simple. We need to write compound formula, the preparation, structure, properties, and uses, as we did in the some compound of boron also. So carbon monoxide, it is not a new thing, new word for you. You heard from so many years about the carbon monoxide. It is one of the gas which is produced by incomplete combustion of carbon. When two carbon will react with oxygen, it will convert into two carbon monoxide. It can somewhere produce from the formic acid also. When formic acid will react with H2SO4, it will produce carbon monoxide and water. In commercially, it is produced by a syngas process, that is water gas process, in which carbon will react with H2O, will give us carbon monoxide and H2, that you did in hydrogen chapter also. If we will talk about the structure is carbon triple bond oxygen, where carbon oxygen have sp hybridization. One sp hybrid orbital, each of the carbon and oxygen overlap to form carbon oxygen sigma bond, while other will form sp hybridization. We'll talk about the properties. It is neutral oxide, it's colorless, toxic gas, odorless, soluble in water. Carbon monoxide acts as a reducing agent, whereas zinc oxide will react with carbon monoxide. After heating, it will convert into zinc plus carbon dioxide. Whereas copper oxide plus carbon monoxide will heat and will give copper and carbon dioxide. So in both the cases, that carbon monoxide will convert into carbon dioxide. Its uses are used in the industrial as a fuel gas and produced gas. It is used in the manufacturing of methyl alcohol also. It is used in the Mond process to purify the nickel from nickelate. So these are the basic carbon dioxide. Now second compound is carbon dioxide, in which formula is CO2, and carbon dioxide can be prepared by reacting carbon plus oxygen. Complete combustion will give carbon dioxide smoke, which is produced in our daily life. C5H12 and 8O2, that will convert into 5 molecule of carbon dioxide and 6 molecule of water. Whereas limestone can be when react with any acid, it will convert into calcium chloride, carbon dioxide, and water. In commercial, carbon monoxide will hydrolyzed, will convert into carbon dioxide. Methane will hydrolyze, will convert into carbon dioxide and H2. This we have done in 10th class also. Now if we will talk about structure, in carbon dioxide, C is sp hybridization, whereas between carbon and oxygen there is a double bond, 2 sigma bond with 2 oxygen and 2 pi multiple bond. As a result, carbon dioxide is a linear monomeric covalent compound. We will talk about the properties. It is colorless, odorless gas. Carbon dioxide is non-poisonous, slightly soluble in water. It is acidic nature, and reaction with lime, it will give limestone. It is used in preparation of aerated drink, which we are drinking. It is used as a fire extinguisher. It is used in manufacturing of washing soda. It is used as a solid. Carbon dioxide, which is dry ice, which is used in refrigerant. Artificial respiration also, where 95% oxygen and 5% carbon dioxide is there. So these are the two compound of carbon. Now we will talk about silicon, which is the second most important element of carbon family. Silicon tetrachloride, formula is silicon chloride 4. Silicon plus 2 chlorine will give silicon chloride. Silica plus chlorine will give a silicon tetrachloride. It is tetrahedral in structure. You know very well, 90% is 90 degrees is the angle. One silicon will be bonded with 4 chlorine tetrahedrally. Its property is volatile liquid, and hydrolysis will convert into silicon hydroxide. Silicon dioxide is the next compound of silicon dioxide, whereas silicon dioxide is the formula SiO2, in which quartz can be heat at 360 degree Kelvin will convert into tridiamide. Tridiamide in 1743 Kelvin will convert to cristobalite. This is the general structure, very simple: silicon, oxygen, silicon, silicon, oxygen, silicon is silicon dioxide. Its reaction with HF will give us SiF4, like similar with SiCl4. Will react with alkali, will convert sodium silicate. It is used in a quartz as a piezoelectric material. It is used in drying agent. It is used in chromatography. It is used in catalyst. It is used in battery. Okay. It is used in accurate clock, modern radio, television, broadcasting, mobile radio communication. Whereas silica gel is used in drying agent, chromatography material. It is used as amorphous silica also. The compound is silicones, in which silicon oxygen silicon bond is called silicones. Formula is R2ClSiO, where R chloride HCl or any other chloride will convert with silicon, will convert into polymerization. This is the polymerization structure. Basically it is high thermal stability, high dielectric strength and resistance of oxidation and chemical. Now we will talk about silicate. Silicate we will study with the help of this book. Dear students, silicates are SiO4 4 negative. This is written here. It is the compound in which anion present are either discrete this way, tetrahedral, or a number of such units joined together through corner by sharing 1, 2, 3, 4 oxygen atom per silicate unit, which is linked together. So this is the basic structure of silicate, where tetrahedral structure is there, silicon in the center. This is shown silicon, and these all are like oxygen. So you can see tetrahedral structure. There are different types of silicates. First is ortho silicates, pyrosilicates, cyclic silicate, and chain silicate, and last fifth is sheet silicate. So there are first ortho silicate. These are the simple silicate which is containing discrete SiO4 tetrahedral. This is the ortho silicates. This is ortho silicates. Zircon is the example. ZrSiO4 is the example. Pyrosilicate is the second type of silicate in which SiO4 2 unit is there. So this is SO4 2 unit both sides. So formula will become SC2 Si2O7, which is known as Thorway-Tite. Cyclic or ring structure. Cyclic mean now it will be 3 silicates here. So you can see SiO96 6 negative. So 1 silicate, 2 silicate, 3 silicate. These are you know very well, this is silicates. These are silicates. These are silicates, Si and O. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 oxygen, 3 silicon is there. Whereas silicon 6, O8 will have 1, 2, 3, 4, 5, 6, this shape, hexagonal shape. And formula is Si6O18, 12 negative. Dear student, it is very simple. Multiply by 2. Double, it will convert Si6, 3 to the 6, 9 to the 18, 6 to the 12. Okay, this is cyclic ring silicate. Fourth is chain silicate. Chain silicate is very simple. It is like up, down silicon. 1 silicon, 2 silicon, 3 silicon, 4 silicon. So formula is SiO3N. It means that keep on increasing. The 2 oxygen atom per tetrahedron are shared like a linear single strain chain in a general formula way. For example, diopside, silicon dioxide, or calcium magnesium silicon trioxide. Fifth one is sheet silicate, in which the silicate will present in the form of sheet. Now the same thing will increase. So Si2O5N 2N negative is there. For example, clay. Clay is the example of sheet silicate. Similar way, sixth we have, which is very important, 3-dimensional silicate. Silica is the 3-dimensional silicate. Quartz, tridymite, cristobalite. These are the 3-dimensional silicate. Now, mostly this question can be asked in exam, zeolite. What is zeolite, and draw the zeolite. If aluminum replace few silicon atom in 3-dimensional network of silicon dioxide structure, then it is known as aluminosilicate, which is acquire a negatively charged cation like sodium positive, potassium positive, calcium 2 positive with negatively charged, example that is called feldspar or zeolite. So zeolite is when aluminum replace silicon atom and it convert sodium positive, potassium positive, calcium 2 positive with negatively charged. That is called zeolite. Zeolite are used in a catalyst in petrochemical industries. For cracking of hydrocarbon and isomerism, ZSM5 is used to convert alcohol directly into gasoline. This question is coming so many times in 1 mark. Name the zeolite which is used to convert alcohol directly into gasoline, that is ZSM-5. Hydrated zeolite are also used in ion exchanger in softening the hard water. So this is very important, the silicates, although I will send this photograph to you for note making. So please try to make your notes properly and try to follow the instructions that I have given, that watch the video from YouTube channel and prepare your own video in the form of student reflection. So thank you. Have a nice day. Hope so this video is helpful for you. Take care. Stay home. Stay safe. Thank you. Have a nice day.